So here we have question 6, part A. And in this question, I'm going to take the value of pi to be 22/7. Now, the saying that in the diagram below, not drawn to scale, shows the cross-section of a circular metal disc of radius 21 millimeters. A square hole with side 6 millimeters is located at the center of the disc. So this is a square hole here. A square has 4 equal sides, so each side is going to be 6 millimeters. And this is the center here, and this 21 millimeters will be the radius of this circular disc. Now, the first question, part 1, is to find the circumference of the disc. So, the formula for circumference is simply 2 pi r. So, I'm going to use c to represent circumference is equal to 2 pi r. And of course, we're taking pi as 22/7. So, this will be 2 multiplied by 22/7 multiplied by the radius, which is 21. Now, I can work that straight on the calculator using the fraction button. So, I can press 2 multiplied by 22, press the fraction button. So, that's 22/7. And then multiply by 21. And you can see we get 132. Now, if I were to work this out without the calculator, I'll put the 2/1 multiply by 22/7 multiply by 21/1. And the only thing we'll cancel here is the 7 with the 21. So I'll say 7 to 7, 1. 7 to 21 is 3. And now I'll have 2 multiplied by 22 multiplied by 3. So if I go on the calculator and press 2 multiplied by 22 multiplied by 3, you can see we get 132. So my circumference is 132 millimeters. Now for part 2 of the question, they want the area in millimeters squared of the cross section of the disc. Now, although this is a circle and you would find the area of a circle, we have this square hole at the center of the circle. So what we'll have to do is find the area of the square hole, find the area of the entire circle, and subtract the area of the square hole from the area of the circle, and that will be the area of the cross section of the disc. Notice they said area of the cross section of the disc, not area of the circle. So area of circle is equal to pi r squared. And of course, we're using pi as 22/7 multiplied by the radius, which is 21 squared. All right, so let's use the calculator and work that out. All right, so I'll put the 22/7 multiplied by 21 and let's square that. And that will be equal to 1,386. So that's 1,386 millimeters squared. Now remember, this is not the final answer. We still have to find the area of the square. And of course, the area of a square is side by side. So area of square is equal to side by side. And each side is 6 millimeters. So 6 by 6, which is 36 millimeters squared. So now the area of the cross section is equal to the 1,386 take away this 36 millimeters squared. So that'll be equal to 1,386 take away 36, which is equal to 1,350. So I'll have here 1,350 millimeters squared. So now for part 3 of the question, they say given that the thickness of the disc is 2 millimeters, calculate the maximum number of discs that can be constructed from 1,000 centimeters cubed. So this is volume, all right, of available metal. So they're saying that 1 cm cube is equal to 1,000 millimeters cube. Now remember, we calculated the cross section of this disc to be 1,350 millimeters squared. Now, if we want the volume, if the metal is 2 millimeters thick, you have to multiply the cross-sectional area by that thickness, which we'll call the height. All right, so this 1,350 multiplied by this 2 millimeters will give us the volume of metal for this disc. All right, so let's calculate the volume of the disc. So volume of the disc is equal to the cross-sectional area times the height. And of course, that cross-sectional area was 1,350 times the height, which is the 2 millimeters. Okay, and that will be equal to 2700 millimeters cube. Now, in order to answer this question, to calculate the maximum number of discs that can be constructed from 1000 cm cube. Now, notice this is cm cube, but our volume here is in millimeters cube. So we'll have to convert this 2700 millimeters cube into centimeters cube before we could calculate how many discs we could get out of this 1000 cm cube. Now, they give us this little conversion here. 1 cm cube is equal to 1000 millimeters cube. So I'll write the conversion this way, that 1000 millimeters cube is equal to 1 cm cube. Now, the reason we put this 1000 millimeters cube first is because we want to convert this 2700 millimeters cube to centimeters cube. So first, I'll have to find out how much is 1 millimeter cube in terms of centimeters cube. So in order to find out what's 1 millimeter cube, if I divide this left-hand side by 1000, I'll get 1. And whenever I do to one side of the equal sign, you must do to the other side of the equal sign. So dividing this by 1000 to get 1 millimeter cube, I'll have to divide this by 1000 as well. So I'll have 1000 over 1000 millimeters cube is equal to 1 over 1000 cm cube. And of course, this is 1 millimeter cube is equal to 1 over 1000 cm cube. Now, I want to convert this 2700 millimeters cube to centimeters cube. So how do I get 2700 millimeters cube on this side? Well, I'll multiply 1 by 2700. Okay, so 2700 times 1 millimeter cube will give us 2700 millimeters cube. And therefore, I must do the same thing on this side, multiply this by 2700 as well. So we'll have 2700 multiplied by 1 over 1000. Okay, so 2700 by 1 is just 2700 millimeters cube, which is equal to 2700 over 1000. Now, because you're dividing by 1000, we just have to move the decimal point 3 spaces here. So you get 2.7. Of course, this is centimeters cube here. Centimeters cube. So I'll have 2700 millimeters cube is equal to 2.7 centimeters cube. So now that I know the volume of this one disc is 2.7 centimeters cube, and the total amount of metal available to me is 1000 cm cube. To find out how many discs I can get out of this 1000 cm cube, I'll have to divide this 1000 by this 2.7. So my number of discs is equal to volume of metal over volume of disc. And that'll be equal to 1000 divided by 2.7. Alright, because this 1000 is centimeters cube and this 2.7 is in centimeters cube. So same units, so we can divide them. So now if we do that on the calculator, we have 1000 divided by 2.7, and that'll be equal to 370.37. And if the 3 significant figures is just 370, but if you want to include a little decimal place, we could stop at a 3 here, and after a 3 is a 7, so this could be 4, so 370.4. So we'll have 370.4 discs. Alright, so moving on to part B of this question 6, we have a globe is a scaled spherical representation of the Earth. The actual length of the equator is 40,000 kilometers and is represented on the globe by a piece of string length 160 centimeters. So basically we have a globe, representing the Earth, and 160 centimeters on that globe, like a map. Okay, so 160 centimeters on this map is 40,000 kilometers actual distance, okay? So this is what we're going to be working with, and I want to know what length of string would represent an actual distance of 500 kilometers. So first, we'll have to do our conversion. So we have 160 centimeters of string representing 40,000 kilometers actual distance. Now, seeing that I want the actual distance in kilometers first, I would write the 40,000 first and then the 160. So I'll write 40,000 kilometers is equal to 160 centimeters of string. Now, what I'll have to find out is what is 1 kilometers in terms of the string on the map, and then I can find out for 500 kilometers. So same principle apply. Whatever you do to one side of the equal sign, you must do the same thing to the other side of the equal sign. So if I want to get 1 kilometer here, I have to divide this left-hand side by 40,000, which means I have to divide the right-hand side by 40,000 as well. So okay, let's do it fast. All right, I'll have 1 kilometer here is equal to, because, I divide this by 40,000 to get 1, which means I divide in here by 40,000 as well. So 160 divided by 40,000, all right, cm. And now if I want to get 500 kilometers, I have to multiply this 1 by 500. So 1 by 500 is 500. So I write it one time. So 500 kilometers is equal to, and I must do the same thing to this side by multiplying by 500. So 160 over 40,000 multiplied by 500. I'll just work this whole thing out on the calculator. All right, so I have my 500 kilometers actual distance is equal to, all right, we put the 160 over 40,000 multiplied by 500. And we get 2. Okay, so that's just 2 centimeters of string. All right, so our answer is just 2 centimeters. So I can just make a little statement here that, 500 kilometers is represented by 2 centimeters of string. Now, continuing part 2 of this question, we have the distances between, this place that's starting with a P and this next place that's starting with a Q. So 2 places, P and Q, right, is represented on the globe. So same globe, which means the same conversion applies. 40,000 kilometers actual distance is 160 centimeters of string on the globe, which is the map. All right. And of course, 500 kilometers is represented by 2 centimeters of string, which means 1 centimeter of string representing 250 kilometers, right? Divide this by 2, you divide this by 2. So those same values applying here. All right, so what we have is that the length of string is 25 centimeters. That is the distance between P and Q. Now they want us to calculate the value of PQ, the actual distance in kilometers. Now I could just go back here and take what we work out here, that 2 centimeters represents 500 kilometers, and then work it back where 1 centimeter represents 250 kilometers. So let's take this here. 2 centimeters represents 500 kilometers. And seeing that we're dealing with the string first in centimeters, I would write the 2 cm first is equal to 500 kilometers. Okay, so if I divide this by 2, I'll get 1, so 1 cm. And of course, I'll divide this side by 2 as well. Okay, I can write that out. That's easy to work out, 250. Of course, this is kilometers. So now we want to know what is 25 centimeters of string. So I'll multiply 1 by 25 and get 25, which means I have to multiply this side by 25 as well. So 250 by 25. So 25 cm, okay, on the map is equal to, and we have 250 multiplied by 25, and we get 6,250. And that will be 6,250 kilometers. So we're going to have 25 centimeters of string represents 6,250 kilometers. So moving on to question 7, which is your sequence question. We have a sequence of figures is made from squares of unit length. The first 3 figures in the sequence are shown below. So we have squares here. We've seen a pattern, figure 1, figure 2, figure 3. So you have to observe this pattern and see what's going on. So I'm seeing this shape here. I'm seeing it repeated here, and then we have these 2 blocks at the side of it. Then I'm seeing the same shape here, see? 2, 2, 1, 2, 2, 1, and then add these 2 blocks at the side of it. So the 4th figure for me would just be repeating the same pattern and adding 2 blocks at the side here. Alright, so here I've just repeated this figure 3 here. And now to continue to make it figure 4. So I just had to add 1 square here and then 1 square above. So I'm adding my square here at the side. And now I'm adding the next square above here. And this would be my figure 4. Alright, so I'm just going to put figure 4 here. Okay, so now part B of question 7, we have studied the pattern of numbers in each row of the table below. So each row, we have a pattern of numbers. Each row relates to one of the figures in the sequence of figures on page 22. So that will be talking about these figures here. Okay. So some rows have not been included in the table. So we want to complete the rows numbered 1, 2, and 3. So we want to complete row 1, which is this row here. Row 2, which is this row here, and row 3, which is this row here. So in row 1, we have here missing and here missing. So we have 1, 2, 3, 4. So what number should go here and what number should go here? So let's look at the pattern. We have 3, 5, 7. You know, that's odd numbers, right? So 3, 5, 7, the next one should be 9. So 9 should go here. Then we have 8, 12, 16. So not so obvious, right? But the difference between 8 and 12 is 4. And between 12 and 16 is also 4. So we're going up by 4 here. So 8 plus 4 is 12. 12 plus 4 is 16. So 16 plus 4 is 20. So I'm writing here is 9. And we could put, this going up by 2, 3 plus 2 is 5. 5 plus 2 is 7. So here will be 7 plus 2, which is 9. Of course, 8 plus 4 is 12, 12 plus 4 is 16, so here will be 16 plus 4, which is 20. Now, when it comes to this part 2 part, where we had to figure out, the number of squares in the figure is 43, what should this figure number be? And of course, what the perimeter should be here. I prefer work out for the nth term first, and then come back and work part 2. So let's figure out the formula for the nth term, when the figure number is n. So when the figure number is 1, the number of squares is 3. When the figure number is 2, the number of squares is 5. And so on. So what's the general formula when, I could put any number for the figure number and find out the number of squares? Well, the common difference here is 2, right? Between 3 and 5 is 2. Between 5 and 7 is 2. So I'll use that 2 and multiply 2 by 1. And I'll get 2. How could I get 3 after that? So 2 by 1 is 2. And if I add 1, I'll get 3. 2 by 2 is 4, and if I add 1, I'll get 5. 2 by 3 is 6, and if I add 1, I'll get 7. So 2 times n plus 1. Now, if you're asking, how did I know to use 2? Well, I always try to use the common difference, right? So the difference between these 2 is 2. Between these is 2, so you call that the common difference. That's why I know I'm going to multiply by 2. So I multiply 1 by 2, and then I add 1 to get 3. I multiply 2 by 2, I get 4. Then I add 1 to get 5. Multiply 3 by 2, I get 6. Then I add 1 to get 7. So my general formula here is 2n plus 1. Now let's see what's going on here now. The common difference here is 4, right? Between 8 and 12 is 4. Between 12 and 16 is 4. So if I multiply this 1 by 4, because 4 is the common difference, how would I get 8? Well, 1 by 4 is 4, and if I add 4, I'll get 8. If I multiply this 2 by 4, I'll get 8, and if I add 4, I'll get 12. If I multiply 3 by 4, I'll get 12, and if I add 4, I'll get 16. If I multiply 4 by 4, I'll get 16, and if I add 4, I'll get 20. So you see what's going on there? We're multiplying the figure number, which is n now, so 4 times n, and I have to add 4. So the nth term for my perimeter would be 4 times n, because n is the figure number, plus 4. Now, trying to figure out part 2 now, what number should come here and here. Let's work with the figure number first, because we have this 43 is the number of squares, and we have the nth term for the number of squares is 2n plus 1, where n is the figure number. So if you want the figure number here, I'll just put this equal to this and solve for n, and I'll get the figure number. So I'll have 2n plus 1 is equal to 43. Transfer the positive 1 across, and we'll have 2n is equal to 43, take away 1. So we have 2n is equal to 42. Transfer 2 across, turn to division. So we'll have 42 divided by 2, which is 21. And therefore, we know the figure number is 21 when the number of squares is 43. So I'll come in here and put 21. And now that we know the figure number is 21 for part 2, we can work out the perimeter, because this is the nth term for the perimeter. So perimeter is equal to 4n plus 4 when the figure number is n. So I'm going to put P is equal to 4n plus 4. And when the figure number is 21, so when n is 21, we're going to have P is equal to 4 times n, which is 21, plus 4. So 4 times 21 is 84, plus 4, which is 88. So my perimeter is 88 when my figure number is 21. So we get 88 here. And that's it. We have completed the table. So now for part C, we have to determine the relationship between the number of squares S and the perimeter P of the figure. So I just brought back the table here so that we can look at the number of squares S and the perimeter P. So now if I want the relationship between S and P, I'll just look at the nth terms here, this 2n plus 1 and this 4n plus 4. And I'll say, what? Well, this one bigger, right? So I'll just subtract these two and see what the relationship between them would be. And now seeing that P is always bigger than S, I'll put the P first, then the S. So I'll put P take away S is equal to 4n plus 4, which is P, take away S, which is 2n plus 1. So I'll have 4n plus 4. If I expand my brackets here, I'll get a negative 2n. And negative 1 by positive 1 is negative 1. I'll bring my n's together, so the 4n together with the negative 2n, and then put the positive 4 together with the negative 1. And this will be 2n, and this will give you 3, so positive 3. So that's P take away S. So now if we look at this table for the figure number 1, and we look at the difference between the perimeter and the number of squares, 8 take away 3 is 5. So for figure 1, and we look at this here, this is the perimeter, take away the number of squares. So if we put figure 1 in here, 2 times 1 is 2 plus 3 is 5. So you can see that this would give the relationship between the perimeter and the number of squares. All right, let's check it for this one here. Difference between 12 and 5 is 7 for the figure number being 2. So you put the figure number 2 here. 2 times 2 is 4 plus 3 is 7. And that way you can get the relationship between the perimeter and the number of squares. That the perimeter is 7 more than the number of squares for figure number 2. So this would be the general formula to represent that. And that will bring us to the end of this video.